Welcome! STEM a Chip presents Let's Make Some Noise. In this video, we're using an Arduino and an active buzzer to bring our circuit to life with sound. An active buzzer has a built-in oscillator and produces sound as soon as it receives power. It is commonly used in alarms and timers and can be easily controlled with an Arduino using simple connections and code. Let's get started and turn simple electronics into something you can actually hear. Let's quickly go over the components you'll need for this project: an Arduino UNO, a breadboard, an active buzzer, a USB cable, and jumper wires. Let's start by placing the breadboard on your workspace. Now take the active buzzer and insert it into the breadboard, making sure each of its two legs sits in a different row so they are not in the same column or directly connected to each other. Next, position the Arduino UNO right next to the breadboard for easy wiring. Take a black jumper wire and connect one end to the shorter leg of the buzzer and the other end to any GND pin on the Arduino. Then, take a red jumper wire and connect one end to the longer leg of the buzzer, marked with a plus sign, and the other end to digital pin 12 on the Arduino. Since this is an active buzzer, we don't need any resistor. It will make sound automatically when powered through the Arduino pin. Once all the wires are connected, plug in the USB cable to power the Arduino and connect it to your laptop. Now that the wiring is ready, let's bring our project to life with some code. Firstly, open up the Arduino IDE on your computer. Then go to Tools, Board, and under Arduino AVR boards, select Arduino UNO. Next, go to Tools, Port, and choose COM3 or another available port if COM3 doesn't connect. Once you've made these selections, you'll see the board and port details appear at the top of the Arduino IDE window. Let's begin coding to generate sound with the active buzzer and Arduino using two repeating beep patterns for a rhythmic effect. First, in the setup function, set pin 12 as an output. This tells the Arduino that pin 12 will send signals to control the buzzer. Inside the loop, the code runs forever, creating two buzzer sound patterns. For the first pattern, the code repeats 80 times, turning the buzzer on and off very quickly. Each sound lasts about 1 millisecond, followed by 1 millisecond of silence, creating a rapid buzzing effect. Next, the second pattern repeats 100 times. Here, the buzzer turns on and off a little slower, with 2 milliseconds of sound and 2 milliseconds of silence, producing a slightly longer buzz. These two patterns alternate continuously, giving your buzzer a dynamic buzzing sound. You can experiment by changing the delay times or the number of repeats to create your own noise machine with different buzzing effects. Once your code is ready, save it with Ctrl+S. Click the Verify button to compile your code and check for any errors. If the code compiles successfully without errors, you're good to go. Click Upload to send your instructions straight to the Arduino and get it running. And here's the sound your buzzer makes with this code. Listen as it buzzes rapidly 80 times with a quick on-off rhythm, followed by a slightly slower buzzing pattern repeated 100 times. These two patterns loop endlessly, creating a fun rhythmic effect. If you enjoyed this project, hit like and subscribe to STEM a Chip for more beginner-friendly Arduino tutorials. Got questions or project ideas? Share them in the comments. We'd love to hear from you, and we might even feature them next time. Thanks for watching, and remember, with STEM a Chip, learning electronics is all about pressing play and making ideas light up.